Hi guys, welcome to another video about Open Mercato. A lot of people asking me about the Open Mercato architecture and how actually this AI assisted engineering impacts the quality of code, quality of the architecture, of the system, its extendability and other stuff. So I decided I will create a short presentation, and this video is just about that. So let me explain how it works. And if you like to get the slides I am presenting here, just let me know in a comment or direct message, and I'm happy to provide you with. Open Mercato is built around modules. Each module can ship backend pages, front-end pages, APIs, validation, database entities, dependency injection wiring, so you can replace components in dependency injection container or add some components. And you can do also some events publishing or subscribing, which is a great way to add some processing to the existing Open Mercato features. Our core idea is that it's open close, so it's open for extensions, for modifying the things you like to have like different way, but by the same time close for modification of the core. So every time you need to make some customizations to your company, to your process, you can do it without modifying the core, which is great because it makes the whole upgradability way different level. So this OCP open close we achieve by using something called at-build time generators that can enable modules, including up-level overrides. So you can override some core modules from your application directory. They got to models.generated TS, entities generated, dependency injection generated, and at root time, Next.js uses those registries to route pages and API calls, while request scope Avilix DI container assembly services and let modules override behaviors cleanly. So the data lives in Postgres. We are using micro ORM with per module schemas and migrations. So the upgradability is very easy and very clean. We also use a custom fields layer for runtime defined models. So every core entity, let's say user, customer, sales, order, whatever we have in the core, you can add your own custom fields with different field editors, with different field types. So it's pretty cool because usually this data model differs from company to company. So the customization on this layer is very, very useful. Finally, every write, delayed, or even read operations amidst the events, and subscribers can handle the side effects like indexing, like workflows. Our core concept is also that the modules are not dependent one from another. So that's why we are using the events. We are also using some injections. I will tell you more on this on the next slides. Injections from one module to another, so you can inject some UI components from sales to customers and so on and so on, without touching the core. We have a problem with mermaid diagram. I will fix it later, but on this slide, I would like to tell you more about the infrastructure and scalability of Open Mercato. So at the center of it, we have the Next.js application, which could be scaled horizontally, run on like few servers whatsoever. It serves the UI and API. The API could be also consumed like headless. I will tell you more on this in a second. So don't be afraid of this monolithic like architecture. Is mostly introduced for the easiness of adding new features to Open Mercato and to support the AI-assisted engineering by LLMs, because we have everything in mono repository. So one single repository where LLMs like Codex or Claude have the full context of the source code and the application. Then, when we go further, we have Postgres SQL database with enabled PG vector for vector search. We have vector search feature as well. It could be switched from PG vector to other vector databases like Quadrant or for example, I don't know, like there's a lot of different vector databases on the market, so you can support them all, like ChromaDB or whatever you like. So it's fully customizable, fully switchable by different strategies. And then we have also cache layer. All the routes like APIs, backend, frontend are cached with tagging in Redis by default, but you can also switch this strategy. So every time something changes in the database, we purge the cache by tags. So this gives us like very high speed and also guarantee that everything is up to date always, and there are no like situations like cache stale or something like this. We also have on this architecture level pretty powerful queue system, which is async, can be used for processing events and can be deployed on many different worker servers. It uses BoolMQ and Redis, but this strategy is also switchable. So if you like to use some other queue provider, like I don't know, like RabbitMQ, whatever you like to use, no problem. You just switch one driver using this Avelix DI container, and it should work out of the box. Here are some details about the search, indexing, and events. All operations in Open Mercato are implemented using the command pattern. Command pattern is great because it also provides us with a way to have like audit logging, what data is changed, when, by who, in which scope, what fields were changed, and also provides us with the possibility to implement the undo feature. So we can undo all the operations like deleting records, adding records, creating records, modifying records. And by the way, we implemented this undo for all modules that are in Open Mercato. So for sales customers, for I don't know, like workflows, everywhere the command pattern is implemented. It causes indexer to work. So we are using quite comprehensive indexing feature because, as I said on the previous slide, we let you to create custom fields for every entity. So you can add any type of data you like to customer, to sales, to user, to role, to any entity, and then we index this data into flat tables as they change. So using the events, so you have guarantee that it always works. By the way, in Open Mercato, there is a load testing included. So we tested the customer module on 1 million plus records. It worked well, like under 1 second on laptop, like per average, because even less, it was like mostly like 100 milliseconds, something like this. So this indexing, caching is doing really great job. Then we have another indexer, which is search indexer, and we are using different strategies for that. So full text, it could be like mailing search. We have tokens-based search, so it's in Postgres database. We are using encrypted tokens. So the even search index is encrypted. I will tell you about encryption in a second. So everything is encrypted, and by this attitude, we are pretty safe, even for extreme cases like remote code execution issue or something like this, where the attacker have access to your server. As long as the KMS, so key management system, is not compromised, it's very difficult to decrypt the information we have in the database. So pretty good information for all sort of GDPR and other risks. Okay, let me go next to the next slides. This tells how the booting and guardrailing works. I will skip it because this is something I already said a little bit about. Next slide is pretty important. It's about headless deployments. Some people ask me like, why the heck you are doing these modules, which is like quite monolithic? Right now everybody is doing headless, and this is the only way to build ERP. Like, I always like to say there is no single way to do things, right? So you can do it many different ways. So what works for you is fine. We decided to go like in this modules architecture because it gives us like first easiness to add new features, to keep to this OCP principle open for extensions, closed for modifications. Then it provides also a very coherent context for AI, for LLMs to know all the source code, all the modules. You don't need to somehow, wire those microservices, API specs into the LLM context, which makes it very difficult to work with. Our assumption is that everybody is going to customize Open Mercato using assisted engineering. We wanted to make it super easy for this case, and we did. But the second assumptions we had, that every module need to be separate. Like we don't create like cross modules joins, cross modules interactions even. So it's banned, it's guard rate in the agents MD and other places. So the modules you're gonna generate or modify, probably they will use features like injections, events, other stuff we provided to have, if they need to have those cross modules interactions, but it's never on the core code level. So you never do things like accessing SACE, Postgres tables from customer module or something like this. You are using API for this. API is for everything. Therefore, if you like to have like headless deployment, it's no problem. So you're gonna then only use the admin panel application and full API. API is well documented, is documented in open API format, is documented in Markdown format, which makes it super useful for LLMs and for code gen. And this diagram shows you like the headless deployment. So different clients, API, then we have this API routed to different modules. Those modules are using some common services like query engine, like comments that I described before, encryption, and other services Open Mercato provides you by default. On this slide, there is the default modules map, which is like the list of the modules we provide by default. Let me just quickly go through it. So out, of course, is authorization, sessions, roles, and ACL. ACL is pretty powerful in Open Mercato. I have a slide about it, so I will tell you more in a second. Then we have something called directory. Open Mercato is multi-tenant. It means like you can have different companies, like different customers served from one single Open Mercato, and all the data is separated into silos like tenants. And then we have also organizations level filtering. So you can create multi-level organization structure with different units, with different organizations. And again, the users you create, the roles you create, the data you create is assigned to the organizations. So you can separate it based on, permissions, who works where, and so on and so forth. Then we have a configuration module, which is like basic system configuration with overrides, with other things. By the way, we have another module not listed here, but but while like connected with configs called feature flags. So you can also feature flags for enabling, disabling, testing some features, enabling it just for some users, sorry, not customers, some admin users, or even for customers. You can use it for customers as well. If you are doing some customer-facing applications, no problem. Then we have entities, so it's data management. And entities is super important. It provides you with this custom fields features, so you can extend every entity in system, adding custom fields, adding custom entities, and modifying the fields you have. And then we have also encryption maps. Encryption maps is super cool because it's field level encryption, something very rarely like seen in ERPs. So you can define the mapping that, for example, the customer first and last name and address is gonna be encrypted. And if just set in the UI, click in the UI, all API calls, UI, virtually everything is using this encryption layer with per tenant encryption keys to encrypt and decrypt the data you have in the database. So as I said, even in very extreme cases like attacker getting access to the server, the data is still encrypted unless the keys or the key management system is compromised. Then we have the query index. Query index is for indexing the custom data you have. So we always try to make the queries as fast as possible. We have special service called Query Engine, which is mapping filtered queries and full text queries into SQL using the indexing mechanism, which is something different than caching. Caching is another layer, but indexing is another thing. So when you have custom fields, we try to map it to flat data tables. So every time you query those custom fields, it's just single SQL query without any, very complex subqueries or joins or whatever. It's made for performance. Then we also have this caching mechanism on top of it. As I said, it's using tagging. So we tag every cache page, cache result with different tags. For example, record ID could be a tag. So if this record changes, it could cause the deletion of the 100 cache keys to make everything up to date. Then we have audit logs, which provides us with the kind of GDPR-like logging who had access to what, and also features like undoing changes, because we are using this comment like pattern for every operation, so we can implement the undo, from MS Word or whatever. So you can undo every comment or redo, no problem. Then we have also attachments, so you can upload files. Users can upload files, PDF files, and also images are by additionally processed by OCR. So the files got searchable, which is great for indexing some, invoices, whatever you have. API keys is a module for the integration, so you can generate API keys to give you access to this open API like APIs. We have also some currencies, dictionaries, of course. Even more important modules are the business domain modules. So the real features, like the UI feature of CRM, of sales, of bookings or catalog or whatever, sits here. So at this moment, we have pretty powerful CRM, we have pretty powerful catalog, and we have pretty powerful sales operations, so quotes. Negotiating the quotes is underway, and everything connected to it. So addresses, payment providers, adjustments, like promotion module is also on its way. So here in this business domains, it's happening a lot. And probably when you will take Open Mercato, it's gonna build something on top of it. You're gonna generate the modules in this domain as well. Then we have some UX oriented modules. We try to keep design system kind of in separate package to let the LLMs always generate the UI which looks and feels the same way. This vector search and full text search, another things I said about already. And here we have those modules. As I said, they are independent one from the other. There are some very minor dependencies from the core modules like directory entities, because we assume that this is something like common for every other module. But other than that, you see that customers, catalog, sales, bookings, they are totally independent from one from another. So this is very, very important assumption. Pretty similar to how Shopify is architected. Not sure if you guys read about the Shopify architecture. If not, I really recommend this lecture. It's super interesting. It's a modular monolith, but the modern way, I would say. Okay. Next thing is about the extensibility. So, as I said before, Open Mercato is extensible by default. So our core assumption is you never change Open Mercato code. Right now we are doing the NPM publication of all core modules. So they even gonna be like just included like npm install Open Mercato sales or customers or whatever, and then you will create a very lean and clean application that is using those core modules where it's suitable, where you need it, and everything else is your custom code, and you never touch the code of the Open Mercato core. You can use those features, you can use those data, everything, but you don't touch the core, which means it's like easy to upgrade and makes that the whole difference, right? Because by having this separation, the burden of maintenance of this quite big business application, which Open Mercato already is on us. It's on contributors, it's on Open Mercato team, and for us it's just savings. You don't need to take care of it. So there is plenty of injection points where developers can inject into those modules extension points. First and foremost is probably where you can override the pages. So you can override like sales order detail view, or you can inject widgets from one module to another. For example, you can inject promotion editor per product from promo module to catalog module, and this will pop up in the UI, not touching the core code, which is great. Then we have this dependency injection container. Every service, every piece of code goes through it, so you can, from your custom modules, your custom apps, you can override some things like query engine or even bus, or every other component you can override, so it gives you a lot of flexibility. Moreover, we emit those events I said before, so every time API, UI, or whatever other place modifies some data, it emits the event for updated, created, deleted records. So you can hook in, you can filter, you can do some additional processing, you can send it to somewhere else. So great flexibility on this level as well. Then we have those queue workers, so you can create event processors that work like async or on different servers or whatever. Then we have this full API, which is great because, as I said before, you can do headless applications using Open Mercato as a backend. You do mobile apps, no problem. You just use our APIs where it makes sense. Add your own services where it makes more sense or whatever you like. We have a migration engine for entities. So if you like to create new data entity, it's going to automatically create the migration. So every changes are tracked, very easy to update the database structure. Search module is fully customizable by adding your own strategies for different full text engines or vector databases, no problem with that at all. So yeah, it's a lot of places. Probably I missed some others as well. But if you go to GitHub Open Mercato and take a look, you probably get answers to your questions if you have any more questions. The last thing I'm gonna go through it is the security model. Security model was super important for us building Open Mercato because it's by definition a software for making the enterprise apps. So two mechanisms that are core to the security is first RBAC, roles-based access control, and ACS, access control lists, and then field level encryption. The RBAC is where you can set which features, like every module can expose its own feature list. For example, users edit or booking managed resources or everything else you can imagine. It's like fully up to you, the module developer, what resources your module is giving access to. Then you have some quite cool helpers, guards that are working on every root level, every API level, every UI level. So they are checking if the current user has access to those resources. If not, it's simply like HTTP error. That's it. By the way, it's working like very much into core of Open Mercato is something you can't easily like remove. So for developers, building new modules is cool because you don't need to remember about it. LLMs also don't need to remember about it because it's something super core to the system and works very well. Also, we have this tenant safety. So tenant ID and organization ID is something super important on every level of Open Mercato, and we use a centralized way for querying the data, query engine. So there is virtually no possibility to have those checks skipped. So it makes pretty safe multi-tenant deployments as well. Then we have this field level encryption, which is something I'm pretty proud of, like that we have this in Open Mercato, because in ERP CRM-like systems, you can hardly find any open source solution providing this feature. In some commercial systems like Salesforce or SAP or some huge enterprise, super expensive applications, probably they have something like this, but by default, usually is said that your data is encrypted in transit because they're using HTTPS, SSL, and that's it. And we are saying no, your data is also safe at rest because the fields in the database they are encrypted with AES. So it's a super strong encryption. And by the way, you can choose which fields on which tables, entities are encrypted, and it's fully configurable. Sorry. So it makes it's really easy to set it up. It's set up by default, by the way. We are using different KMS strategies, HashiCorp, Vault, or others, so you can also configure it. If you don't like to make this deployment complex or just using for development purposes, that's also fine because we are using fallback keys, so you can set the encryption key just in environment, and that's it. It's gonna be encrypted. Okay, cool. Here we have some extension slides to this first Open Mercato architecture. I probably said everything about it already. This is the request flow. If you like, I am happy to send you the slides. So just let me know. And probably in the next video, I'm gonna do some real-time demoing the features or the architecture features I described today as well. So Thank you very much and see you soon.